LangChain and LangGraph. Two libraries, same company, almost the same name, and everybody talks about them like they're interchangeable. They're not. And if you're building a real automation with an LLM inside it, mixing them up will cost you weeks. So here's how we're going to settle it. I run a real content pipeline. One live stream goes in, and it fans out into a long-form video, a batch of vertical shorts, and social posts across 7 platforms. Not a toy demo, the real thing, running every week. And one question drives this whole video. Could that pipeline live in LangGraph? And would that actually be better than what already works? By the end, you'll know exactly what each library is for, what code you'd actually write to map a workflow onto a graph, and how to tell whether you even need it. Let's start with the one-liner that untangles the whole thing. LangChain is a parts bin. LangGraph is a control flow engine. Hold on to that because everything else follows from it. LangChain is a box of components. Model wrappers, prompt templates, output parsers, tools, retrievers, plus a piping syntax called LCEL that chains them together. Look at the shape of it right here. Prompt, pipe, model, pipe, parser. A question goes in one end, clean data comes out the other. LangGraph is a different animal. You define nodes, you connect them with edges, and one shared state object flows through the whole thing. And the code reads exactly like the picture. Add node, add edge, compile. The graph you draw on the whiteboard is the program. And that's exactly why LangGraph exists. An LCEL runs in one direction and remembers nothing, which is great for prompt in, answer out, and terrible at loops, conditional routing, pausing for a human, or surviving a crash halfway through a run. Now, here's the part that surprises people. You do not need LangChain to use LangGraph. A node is just a Python function. It can call a model, run a shell command, hit an API, whatever you want. And look how small the contract is. Your function takes the state object in, does its work, and returns just the fields it changed. Then, one line registers it on the graph, add node, right here. If you can write a Python function, you can write a node. So here's the mental model to keep. LangGraph is the spine of your application, and LangChain lives inside individual nodes. In the places where the work is genuinely linear and LLM driven, you reach for it only where it earns its keep. All right, let's map my actual pipeline onto a graph. One live stream comes in, and it fans out into 3 lanes. The long-form edit, the shorts lane, and a repurpose lane that turns the transcript into posts. Then everything converges on a single publishing layer at the end. What I just described has a name. When one input splits into parallel branches, that's a fan out. When those branches come back together at one point, that's a fan in. Textbook distributed systems pattern, and LangGraph speaks it natively. Every node reads and writes one shared state object, and defining it is code you already know how to write. It's a typed dict, one class, one field per thing the pipeline cares about. Right here, the batch metadata, the transcript, the clip list, the draft queues. For the fan out itself, LangGraph gives you the send API. You write a little routing function, and the trick is all in its return line. Look at this. Instead of naming one next node, it returns a list of send objects, one per clip, and every send spawns its own parallel worker. Now, how do 20 parallel workers write results back without stomping on each other? You mark the field with a reducer, right here. That annotation tells LangGraph to append each worker's result instead of overriding the whole field. One line, and the fan in handles itself. Now, a question I see everywhere. Is a LangGraph, a DAG, a directed acyclic graph? Honest answer, it can be, but LangGraph doesn't force it. Loops are allowed on purpose, like a draft lint, redraft loop that keeps going until the content passes. But here's a design rule worth stealing. Peers never spawn peers. Only the orchestrator owns the graph. Workers do their job and report back. And that one rule is what keeps the whole thing acyclic and sane. Once you've got multiple agents in a graph, there are 3 shapes people build. Shape 1 is the supervisor. One orchestrator reads state and dispatches simple workers. Fixed, predictable, safe. For a pipeline with strict ordering, that's the right call. Shape 2 is the swarm. Flat peers handing control to each other. No central boss. Flexible and chaos prone, right? You'd want it when work gets negotiated dynamically, like a breaking news batch jumping the queue. And shape 3 is hierarchical teams. Supervisors of supervisors. Each lane becomes its own mini pipeline with its own boss. You graduate to this when a single lane gets complex enough to deserve one. One thing that gets missed, nodes don't have to be agents. A node can be a deterministic script or a reasoning LLM. Most pipeline steps should be plain code. Save the agents for steps that need real judgment, like picking clips or drafting posts. Now we get to the feature that actually sold me, checkpointing. You attach a checkpointer, and LangGraph saves the state after every single node. If the process crashes, you don't restart the pipeline. You resume it, right where it died. Think about what that means with real numbers. A 40-minute render that dies at minute 38 should cost you 2 more minutes, not 40. A common way to store checkpoints locally is SQLite. And here's the clarification most people need. SQLite is a real relational database. It's just serverless and file-based. One checkpoints file on disk. No server to run, nothing to administer. And look at what that feature costs you in code. You open a SQLite connection to a file, wrap it in a SQLite saver, and hand that to compile. Right here. From that moment, every node run is checkpointed automatically, and you never write a single line of SQL. But resuming has a trap, and this is the part that bites people in production. Say a post actually goes out to a platform, and then the call crashes before it records success. The naive resume runs that node again. Congratulations, you just posted twice. The fix is a property called idempotency. An idempotent operation is one you can run 10 times and get the same result as running it once. Rendering a video is naturally idempotent. Same input, same output. But posting to social media is not. So you wrap the dangerous steps in a guard, and the pattern is 4 steps. Record attempted, do the action, verify it actually happened, then record complete. On resume, the node checks state first and skips anything that's already done. And you set retry policies per node. In code, it's 1 keyword argument on add node, right here. A retry policy with max attempt set to 1. Downloads and renders can retry all day. They're safe. Posting nodes get 0 retries, because at least once is the wrong guarantee for a public action. Here's my favorite idea in this whole space. Your operational rules should not live in a prompt saying, please don't do that. They should be structurally impossible to violate. Take a real rule like, never post to 2 platforms in parallel. Don't ask the model nicely. Build one posting node that everything funnels through, so the topology itself forbids parallel posts. And never auto-retry a post. Is that retry policy from a minute ago set to 0? Not a sentence in a prompt. Validation works the same way, and look how little code the redraft loop is. Add conditional edges right here. The lint node runs, a router function reads the result, and the mapping says pass moves forward, fail routes back to the drafting node for another round. Constraints as structure, not prose. Prompts get forgotten. Topology doesn't. Now, no matter how automated this gets, I still want to approve content before it ships. LangGraph handles that with interrupts. The graph pauses at a node, persists its state, and waits for a minute or a week. Then it resumes from that exact point. And in the node, it's 1 call. Look at this. You call interrupt and hand it whatever the human needs to see, like the draft. Whatever answer comes back when the graph resumes, approve, edit, or reject pops out of that same call. And where does the graph live while it waits? Frozen in the checkpoint, on disk. Your machine can reboot. The graph is still sitting there, waiting for your answer. Those answers can carry structure too. Approve, edit, or reject with notes. Your notes go into state. The graph routes back to the drafting node. It reruns with your feedback and pauses again. Loop until you say yes. So the honest question, because my pipeline already works, right? A human-driven setup is flexible, and when a script breaks mid-run, I can jump in and fix it on the spot. That flexibility is worth something real. What LangGraph buys you is resumability, rules enforced by structure, and real observability. What it costs you is new infrastructure to learn, new failure modes, and less ability to jump in and repair things interactively when something breaks mid-graph. Here's the signal that tells you it's worth it. Frequency and pain. Daily runs, crashes, eating re-renders, tired of sequencing every step by hand. LangGraph earns its place, running twice a week and driving it by hand just fine. It's premature. Keep what works. And if you do migrate, don't rewrite everything. Use the strangler fig approach. Pick one small low blast radius lane, prove checkpointing and idempotency there, keep the old flow running next to it, and expand only once you trust it. Let's recap the whole mental model in one breath. LangGraph is the spine. LangChain lives inside the nodes. State plus checkpoints give you resumability. Idempotency makes resuming safe. Hard rules live in the topology. And humans gate the graph through interrupts. The meta lesson is bigger than these two libraries. Don't rewrite working automation because a framework is trending. Rewrite it when the pain is real. And start with the smallest piece you can. There's more I didn't cover: observability and tracing, scheduling, and the actual migration walkthrough. Those are their own videos, so click that subscribe button if you want them, and drop a comment. What pipeline would you rebuild in LangGraph? I'm going to catch you guys later.